The pressure exerted by a fluid material in a vessel is directly proportional to its height multiplied by its density. Hydrostatic pressure or head pressure is the force produced by a column of material. As the height of the material changes, there is proportional change in pressure. To calculate hydrostatic pressure, the density of the material is multiplied by the height of the column. The level of fluid in a column can be determined by dividing the pressure value by the density of the material. To find pressure, a gauge is placed at the bottom of the vessel. With the water having a density of 0.0361 pounds per cubic inch, the level of the fluid is calculated by dividing the head pressure by the density of the fluid. Another method of calculating the level of material in a vessel by weight is using load cells. Load cells are comprised of a strain gauge bonded to a support and convert a force or load to an electrical signal. As force or weight is applied to the load cell, the strain gauge deforms and causes the electrical resistance to change. In tension, the area narrows and the resistance increases, and conversely, in compression, the area thickens and resistance decreases. Connected to a bridge circuit, the force measured is proportional to the output voltage. The output voltage is converted to a level measurement when vessel weight and vessel fluid density is known. An example: to determine the level measurement of a column of water that is 2 feet tall and diameter of 0.5 feet is solved by the following steps. The first step is measuring the weight of the vessel. Next, measure the weight of the vessel with fluid. The weight of the fluid is determined by subtracting the weight of the vessel from the weight of the vessel with fluid. The volume of the fluid is then derived by dividing the fluid weight by the density of the fluid. The level of the fluid is finally calculated by dividing the volume of the fluid by the surface area. Hydrostatic pressure can only be calculated from an open container. Within a closed vessel or pressurized vessel, the vapor space above the column of material adds pressure and results in inaccurate calculated values. The vessel pressure can be compensated for by using a differential pressure transmitter. This device has a high-pressure side input and a low-pressure side input. The high-pressure input is connected to the bottom of the tank to measure hydrostatic pressure. The low-pressure input of the differential pressure transducer is connected to the vapor space pressure. The transducer subtracts the vapor pressure from the high pressure. Resulting is a value that represents the hydrostatic head proportional to the liquid level.